All right. So now, after the descriptive statistics or basic descriptive analysis, now we will shift towards the actual regression algorithm. Okay. So it's very simple to do the regression, but before that, we will see what is regression, why it is used, and how we are going to implement regression analysis on this particular data set. Regression analysis, I'm going to write. So let me explain. Regression analysis is generally means we can use regression for many other purposes also. We might use. We are going to use regression analysis is generally used for predicting next values in the given data set. Okay, so this is our intention. Based on our given data set, what will be the next value? What will be the value of impression on 31st day? If there is an impression, if there is given number of clicks, what will be my revenue? Okay, so I will write here in this project, we are interested to find predictions for sales based on impressions and clicks. Okay, so based on impressions, what will be our sale value tomorrow? Based on clicks, what will be our sales value tomorrow? This is what we are going to do in the regression analysis. Okay, for this we need a library. Which kind of library? sklearn. Okay, so this is how sklearn library is imported. If you don't have sklearn library pre-installed in your Python, so first before doing importing, what you have to do is you have to install that pip install sklearn. Okay, so now you have to install it. If you don't know how to install this particular library, you can just google it, how to install sklearn in your laptop, in your Python. Okay, and you can run this particular thing. So once you run this, automatically it will be downloaded for your Python version, and then you do not have to always keep on installing. You can directly import sklearn. Currently I already have pre-installed, it will say already satisfied. Okay, so now sklearn library has been taken. Now only the task remaining for my regression analysis is, there are two different things. First thing is, what I will do is I will first apply linear regression algorithm. Okay, I have already told in my other videos that regression analysis is a kind of algorithm in which we generally predict next values based on our previous values. Okay, so what we have to do is we have to use any kind of regression algorithm which will be suitable for our data set. There are many different kind of algorithm. It can be linear regression, multiple linear regression, polynomial regression, lasso range, etc., etc. Many kind of regression, from which currently we are going to apply linear regression algorithm first. How to apply that? So let us see. First of all, I want to apply my linear regression based on impressions, clicks, and revenue. Means what I am telling is, we have to give some parameter, based on we are going to predict another parameter. So my revenue is the parameter or a factor or a variable which is dependent parameter, dependent variable, because revenue depends upon how much impressions are there. Revenue depends upon how many clicks are there. Clicks and impressions are independent variables. So first we will see that if there are any impressions, how much is the revenue? If there are any impressions, how much is the revenue? In this way, if we are giving any random impression value, what will be our revenue for that? Our model will give the predictions. This is what our intention is. In short, we are going to define two different variables, x and y. That variables will be independent variable and dependent variable. So I'm going to define variables. I will write independent and dependent variables. Okay, so this I'm going to write it down. Let us see how we have to write it down. So now let us define the variable x and y. How we define that? So what is going to be in the x? In x, we are going to insert the values only for the impressions. How to keep that? How to do that? All the data is stored in files. From the file, I'm going to use ilog function. From that ilog function, I am going to use all the rows. So if I'm mentioning here colon, so it means all the rows I want. And which column I want? This is the zeroth column. This is the first column. This is the second, third column, fourth column. Why? Because indexing in the Python starts with 0. So what is the column of impression? That is 1. So I'm mentioning here 1, and we will execute. Let us see what is there in x. You can see that 3, 2, 5, 8, 9. So you can see that that value is of the impressions. So my all values of impressions are in x now. Okay, same thing I'm going to do with the y, and my this is my independent variable. First of all, you should understand impressions are my independent variable. Okay, and this is going to be my dependent variable. Okay, so here I'm going to write all the rows I want, which column I want. Column is this is the zeroth column, first, second, third, and this is the fourth column. So revenue means the fourth column. Okay, all right. So here I will put down here fourth. Done. All right. So let us see what is stored in the y. All the revenue is stored in the y now. In this way, my variables are ready. For this variable to be in the array format, currently you can see that x and y, if you print, they are in the vertical column format. I want in the array format. So I will write like this. If you print x, you can see array format. If you print y, you can see array format. Okay. So for x, I want x to be in my vertical format. Okay, so how to give that vertical format? Just by, you can do it by reshape also. Okay, so in this way. Now what is stored in x? In this way. Now why we want x in the vertical format, why we want y in the horizontal format? Let us see slowly. Okay, all right. So after this, what we have to do is we have to now train our model. We have divided our data set into two different variables. Means what? This was our data set. Where is the data set? This is our data set, and we have divided into two different parts: independent variable, dependent variable. We have taken only two different columns. We are going to check that how impressions are affecting my revenue. This is my intention. Now, already we have imported my sklearn library. What I'm going to do is, on the basis of this sklearn library, I'm going to import a function which is called as train, test, and split. This a single function: train, test, split. What will happen when we are going to use that? Let us see first of all. Okay, so from sklearn library. Okay, whenever we are going to use library, we have to write in this format. From that library, there is a sub library called as model selection. Okay, so model underscore selection. From this, we have to import the function. Which function? Train, test, and split. This is my function. Why I'm going to use this function? Because I want to divide my entire data set into again two different parts: training data set, test data set. I want to split that data, and that's why I'm writing train test. We have to split it. Okay, what is training data and test data? See, this is a machine learning algorithm. Means I want to teach my machine that in this way you have to perform regression. If I want to teach anything, what I will do? I will give you few examples, and then I will take your exam. Similarly, if I want to teach my Python that you have to perform regression in this way, so what I will do is I will give few examples of my data set like this. If there is value of impression 32,000, revenue is this much. 15,000, revenue is this much. 9,58,000, revenue is this much. So I'm giving examples. What is the impression? What is the revenue value? What is the impression? What is the revenue value? In this way, machine learning algorithm or my Python will understand what are the values, and at that values what are the revenue, and then machine, my Python, will try to understand what is the pattern going on. In this way, machine will try to learn what are the values and then how it is going to affect my revenue, slowly slowly slowly. So one thing is clear, sir, as much as possible we are giving large number of practice data to our Python compiler, that much accuracy will be higher. Correct? Means what? Training data should be higher and test data should be less. Test data means what? Let us take a simple real life example. Like if I want to teach you addition, what we can do? We can just start with 2 plus 2, 3 plus 3, 4 plus 4. Then I am asking you in the examination, like what is 3 plus 3? What you will tell? Sir, already you have taught us three examples, from which one example you have asked in the examination. This is called as training data of three example, and one example is of the test data. We were already knowing the answer of the test exam, and we were trying to predict what is the answer. Okay, but in the case like I'm asking you, I'm giving you examples of 2 plus 2, 3 plus 3, 5 plus 5, but I'm giving you in the examination a different question, 15 plus 18. So how you will solve that? Your accuracy will be very much less, because you have never seen such kind of summation. So how your summation will be increased? How you learn the mathematics or any subject? By spending too much of time, by doing practice, habits, again and again doing the same things, exploring new questions and everything. Correct? Same thing. Training data should be higher. As much as the training data is high, accuracy will be great. Test data means from this data set only we will hide few rows from our machine. Like last few rows will be hidden. We will not show to our machine. That will be your test data. We will give upper all rows to our machine, and we will tell machine that this is impression, this is revenue, this is impression, this is revenue. In this way we will give, these are questions, these are answer, these are questions, these are answer. But next time we are only going to give them questions, and we will ask them answers. My Python will give me some answers, and as well as I have my own answers. These are my original answer. I will compare what is predicted by my Python and what is actual value. The difference between them will decide how much will be the error. This is the concept of training and test data. So how to divide that? Already I have divided my entire data into two variables, x and y. Again I am going to divide it in the horizontal way. Means training data of x, test data of x, training data of y, and test data of y. In this way, entirely four different sections will be there of our entire data set. Okay, so let us write that. X train is my variable which I am defining. X test is my another variable which I am defining. Y train and Y test. These are just the variables which I have defined at a time. You can define it separately, but from this function we can define it at a time. Okay, now which function I want to use? This function. So I'm going to use this function. So my function will ask what you have to divide. I'm going to give them two variables. Which are two variables? X and y. Here is your first variable, this is your second variable. Okay, and with the help of this particular variables, my entire data set will be divided. But in what proportion you have to divide? That proportion will be told by us. Okay, how to tell that? Test size equal to, you can tell that test data should be 0.3%. 0.3 means what? 30% or 20% or 10% or 50%. It depends upon you. And just now we have mutually decided that test data should be smaller and proportionally training data should be larger. So let us consider 70-30 ratio or 80-20 ratio. So let us consider test data is of 0.2 means 20%. Rest all the data will be training data. And then we have to give random state equals to some constant values like 0. So random state I have already defined in my other videos. Still I will tell that random state means nothing but whenever in your entire example you are going to assume any kind of random variables. Okay, so that random variables or random values will be constant throughout your entire code when you define this random state. Okay, slowly you will understand this thing also. And in this way, when I will execute, my training model has been done. Now if you want to see that what is stored in xtrain, so you will see that yeah, the same array is there, sir, but xtrain is what? Training data. So 80% of x is stored in xtrain, 20% of x stored in xtest. So total 30 different rows are there. 20% of 30 means what? 6. 1, 2, 3, 4, 5, and 6. 6 different values are there in test. Correct? Similarly, y train and y test are there. This is called as training of your model. Model has been trained. Now, I want to, model not has been trained, model has been, sorry, the data has been splitted. Just now I have split the data. Now I want to train my model. How to train my model? Again from my sklearn library. So from sklearn, there is a sub library which is called as linear model for the linear kind of algorithms. Okay, so I'm going to import actual function which is linear regression. This is my function. Okay, from this function, how to train your model now? I'm going to save this function into a small variable. Always I'm not going to write that. So LR equals to, this is my function. Okay, I've stored my function linear regression as LR, small shortcut only, nothing else. Now LR fit function, fit is used for training your model. What are my training data set? X train. How you will train your machine? Based on X train. X train are your impressions, and you're telling to your Python that if impressions are given, these are the revenue. Where are the revenue stored? In the Y train. Okay, so in this way you will train your model that X train, correspondingly there will be the Y train value. So in this way your model has been trained. As we have very much less data set, so it is very easy for Python compiler to give the training within fraction of second. But if your data is too much high in crores or lakhs, it might take some time. Okay, now I will define a variable, let's say y prediction, because ultimately we are going to predict y. Y means revenue, x means impression. So y prediction equals to, now carefully see that from LR function we are going to use predict function. Okay, so I'm going to use predict. What I'm going to predict? Whatever revenue is there. But for that question needs to be given na? Based on what prediction should be done. So based on impressions. So already we have trained based on X train, Y train. So there are two more values remaining, X test and Y test. X test means what? They are testing samples. X10 means testing samples of impression, and Y test means they are actual answers of revenue. So I will give to my Python like X test. Okay, so yeah, so here underscore it will be not there, dot will be there because it is a function. Okay, so in this way I will predict what will be the values of Y. See, based on X test. What was the X test? If you want to see, I will show you what is stored in X test. These are X test. This means what? Last six values of my entire data set are my test variable. This one, two, three, four, five, six. In this way. Okay, that are my variables. For that, if this is the impression, what will be the revenue? This is the revenue. For this much impression, what is the revenue? This much is the revenue. Now, these are not actual values. These are predicted values. Where are the actual value stores? That is in the y test. By test. These are my original values. Now you can see that prediction values, original values are almost similar or everything is similar. So it might give you the 100% accuracy. Almost not, it is entirely similar. So your accuracy is 100% for this particular example. Why? Because you will see slowly that when we will plot the graph of impression and revenue, so it will overlap each other. All right. So whenever but accuracies need not to be always 100%. It will change depending upon anything. Okay, so let's say I want to predict anything now. So let's say new revenue. I want to predict new revenue. So I need to use LR, because in LR model my entire model is been stored. LR, this shortcut, my entire model is been stored. So LR predict, what I want to predict, I will write here in square bracket. I will give impression. If only one is the impression, what will be my revenue? Impression is only one. What is my revenue? See, you can see that 0.1 rupees will be my revenue. If impression are 10, what will be my revenue? This. If impressions are, let's say, 500, what will be my revenue? If impressions are anything, one, you can type anything. Okay, correspondingly revenue will be given. Now this revenue need not to be always correct. You have to see that actual revenue and then you will decide. Correct. Now how we are going to use this particular model? So you have applications of your digital marketing where you can predict that what will be the forecasted impressions tomorrow. Okay, so approximately, let's say tomorrow your impressions will be something around 40 lakhs. So you can enter here 40 lakhs and you can see what will be revenue. So okay, revenue will be my 4 lakh 10,000, and you have to see that tomorrow whether you are getting that 4 lakh 10,000 or not. Okay, and then correspondingly you will understand everything is going good or bad and how much scope of improvement is there. Okay, similarly how we have done it for impressions and revenue, you can do it for clicks and revenue also. You can use both the factors, because revenue is not only dependent on impressions, revenue is not only dependent on clicks, it can also depend on combined effect of revenue plus click. Okay, slowly we will go into complexities, but in this project you just have to predict till this much, only this much, and then you are done with the simple linear regression. Slowly we will see multiple complex kind of data and then how we have to predict the data. Okay.